factors affecting corrosion on metal surface. So here if we take iron nail pieces, and you bring it in contact with the air and water together, it is in the form of moisture. You find that here the process of rusting takes place. This is A. Again, iron nail pieces, if you take and if you mix it with oil plus water, here also rusting takes place. Rusting stage 2, it is B. Again, so between these two you find that is therefore rusting in A is faster than rusting in B. That is, it is slower. So from this, that means from this observation, what you are noticing is, that is, if you go to the mechanism, iron solid plus, that is O2 gas, that is air, and if you take moisture, if you take moisture, that is 4H plus ions. 4H plus ions plus 4 electrons gives rise to, we can simply take this as Fe2O3 of dot XH2O. That means rusting, corrosion on metal surface. Corrosion on metal surface. We have 4 hydrogens and 2 oxygens. So we have 4 hydrogens and 2 oxygens, X number of water molecules. This is metal oxide hydrated. Already it is rusted. So here one thing what you have to notice is, we also call it as rusting spots, rusting or corrosion spots. If you take a piece of iron and if a small spot is created, this spot, you find that this is an iron piece, iron rod. Here you can find one spot. This spot is called corrosion spot. It is called corrosion spot. This corrosion spot, it acts like a anodic spot, because it is acting as an anodic spot. So corrosion spot undergoes oxidation, and this, during oxidation, it gets de-electronated. So here if you take this anode spot on metal surface, it undergoes de-electronation, and here iron solid, it gives Fe2 plus 2 electrons. These 2 electrons which are obtained are called free electrons. And what is happening here is, if you take a piece of iron rod, you can see one spot. From this spot, the electrons are produced. These electrons, they go and create one more spot, and again from here one more new electron will come, and this electron will create one more spot, and this is sequence chain migration of that is anode spots on metal surface. anode spots on metal surface. So therefore we can come to one conclusion. We can simply say that you can take iron plus O2 plus 4 H plus ions will therefore give you, if you take 2 moles of iron, 2 moles of Fe, 2 moles of Fe, 2 plus 2 H2O. This is the mechanism taking place in the, this is rusting on metal surface. Iron surface. This comes under the rusting or corrosion on the metal surface. So prevention of corrosion. Next, if you go for prevention of corrosion, we can take, that is protection of metal surface by painting. Painting is done through bisphenol. Then you can also use sacrificial anode electrode to protect metal undergoing corrosion. Example, imagine that if the cupric ion, if the copper ion is getting reduced, then this cupric ion, if it is subjected to rusting, then the zinc metal is acting as anode, and if it is acting as anode, it oxidizes. If it oxidizes, it reduces the cupric ion. It prevents the cupric ion to undergo reduction. It becomes Cu solid plus Zn2 plus. So this mechanism involves sacrificial electrochemical anode to prevent the rusting of copper. Copper is prevented from rusting by coating the copper with the zinc coating. Zinc will try to protect the cupric ion, and the zinc electrode in the form of anode electrode, it is reducing the cupric ion to metallic copper, and by itself it is undergoing oxidation. So here copper is protecting the, zinc is protecting the copper electrode, and zinc by itself is getting oxidized. So such mechanism we can also call it as electrochemical. Such mechanism we can call it as such reaction we can call it as electrochemical reaction. We can call such reaction as electrochemical reaction.